In this video, we're going to do a couple of related rates, and since I've been a little sick, I might be coughing and clearing my throat, so I apologize now. On excuse me, on this example, we're talking about police officers a half a mile from an intersection. We're driving north toward the intersection at 40 miles an hour. At the same time, a car is leaving the intersection a half a mile east of the intersection and driving east, so away from the intersection, at some unknown speed. The police officer's radar gun indicates it is 25 miles an hour when it's pointed at the other car, and we want to know the speed of the other car. This diagram's already built for us, so this screams Pythagoras, A, B, and C. So I know that A squared plus B squared is equal to C squared. They also tell us that A is 1/2 and B is 1/2. C I'm going to go ahead and find right now, but I'm not going to put that in until after I've done derivatives, but I'm going to find it now. So I have 1/2 squared plus 1/2 squared is equal to C squared. So 1/4 plus 1/4 is equal to C squared. So I add those together, take the square root, so I have 2, or square root of 2 over 2 is equal to C. Now, they're also giving me the derivative of the police officer's speed with respect to time, the dA dt, and this is going to be a negative 40 miles per hour. The reason it's going to be negative is because in this direction, we are going closer to the origin. That means that it is a decreasing, so we're getting closer to the origin, we're going toward it. So for us, because of the fact that as we get closer to it, the distance is decreasing, so my dA dt is a decreasing, so it's a minus. My dC dt, that's the other thing they give me, which is 25 miles per hour, and that's positive because it is increasing. What we want, however, our want, is the dB dt. So we want the dB dt, so we're going to use Pythagoras' theorem, and we're going to go ahead and do the derivative. So we're going to do d dt of a squared plus d dt of b squared is equal to d dt of c squared. So 2a dA dt plus 2b dB dt plus 2c dC dt. We have a replacement for A, we have a replacement for dA, we have a replacement for B, we have a replacement for C, and we have a replacement for dC dt. And again, what we want was the dB dt. So let's go ahead and put in all the values. So I have 2 times 1/2 and minus the 40 miles per hour because it is getting closer to the origin, so the distance is decreasing, plus 2 times 1/2 dB dt is equal to 2 times square root of 2 over 2 and then 25. So go ahead and multiply through. The 2's cancel there and here and here. So I have negative 40 plus dB dt is equal to the square root of 2 times that 25. So dB dt is equal to, well, I'm going to go ahead and put this in my calculator, and I get the speed to be 75.6 miles per hour. So unless the speed limit is 75, they're not going the speed limit. So that is 75.6 miles per hour. Now, if the speed of the gun indicates a negative 25, then what changes on this is, let me just erase really fast here. The thing that changes is that this will be a negative then, so it is the 2 times 1/2 multiplied by a negative 25, And so I'll have negative 25 over here, root 2. So when I put this in my calculator, what I'm going to get is 4.6 miles per hour, with some decimals trailing, so 4.6 miles per hour. So there's that example. Let's take a look at another example. And this one's similar to my first one. I have a lot of Pythagorean theorem going on here. So let's go through this with Pythagoras' theorem, A, B, and C. What we are given is the dB dt. That's the rate of the person walking away, which is 3 feet per second. What we want is dc dt, or equivalently we want dA dt. The rate at which this is being lifted and around the pulley is the rate in which the rope is being moved away. So the dA dt and the dc dt, dc dt, there we go, should be the same. So let's do the Pythagoras' theorem. We have a squared plus b squared is equal to c squared. Well, the height, this distance right here, is 40, and that's not going to change. So that's going to be 40 squared. And then plus b squared is equal to c squared. Let's do the derivative. Well, the derivative of 40 is since 40 is a constant, that's just going to go to 0. So I have d2b dB dt is equal to 2c dc dt. Now we know what we know what b is, because we want when we're 10 feet away. So we have a replacement for b. We have a replacement for dB dt. We do need to find c, and the way in which we're going to find c is we are going to use Pythagoras, where a is 40, b is 10, and then I'm just chasing c. So c is going to be the square root of 1600 plus 100. So c is going to be equal to, I'm going to get my calculator out here, and so I'm going to do the square root of 1600 plus 100. That gives me 41.23. Now that I have all the replacements, let's go ahead and put those replacements into place. I'm not sure what that's doing up there, so let's just get rid of that. It's weird. Okay, so anyways, back to what I was doing. I have 2 times b. B was 10. dB dt was 3. Is equal to 2 times, and it was 41.23? 41.23 dc dt, and that's what I'm chasing. So I have, the 2 is going to be the same on both sides, so I can cancel that out. So I have 30 divided by 41.23, which is going to be dc dt. And so my final answer is going to be 30 divided by that 41.2, which gives me 0.7276 feet per second, which is dc dt. So that's the answer for the first part. So I'm going to put in there 0.7276. Then they asked me for when it is 30 feet away. So all I have to do is find my replacement for c, which is not going to be the 41.23. And I'm just going to do the same thing, but now I have a replacement for c that is different. Everything else will be the same. Let's take a look at our next one here, which is a conical shape. We have a tank with a conical shape with a vertex pointed down and a radius of 10 feet at the top and 24 feet high. So the first thing I always do is draw my lovely picture. So it's perfectly shaped. they tell us that the radius is 15 feet, and they tell us that the shape is 24 feet high. We want to know if the water flows in at 30 feet cubed per minute, how fast is the depth of the water increasing when it is 12 feet high. So when this is 12 feet high, they want to know what is the rate of increase. What they want then is dH dt. So we have the volume of a cone, which is 1/3 pi r squared h. So we want dH dt. We don't want the r there. We are also given this, which is the dV dt. So we're going to have to get a replacement for r, and the way we're going to do that is we're going to look at our cone here. So I'm going to go over here and look at our cone. So I have these triangles going on. If I cut the cone, or my tank right down the center, and then again in a quarter, this is 15, and the height is 24. So from top to bottom, the height is 24, and from side to side, that's 15. And then this is my r is to, and I put an h there, r is to h. So we want to get the radius in terms of h. So 15 is to 24 as my radius in general is equal to the h. Now eye on the prize, we want dH dt. So 15 over 24 reduces to 5 over 8. H is equal to r. So that means I have a replacement for r in my formula over here in terms of h. So my volume is equal to 1/3 pi. My r gets replaced with 5 over 8 h squared multiplied by h. So v is equal to 1/3 pi. And then I'm going to square that so I get 25 over 64 h cubed. Now I'm going to take the derivative with respect to time. Excuse me. I get dv dt is equal to 1/3. It's really bad, 1/3. 1/3 pi. 25 over 64. 3h squared dh dt. So I have the dv dt replacement. I know what pi is. This 3 and this 3 cancels. And I also know what h is. So putting everything in that I know, I have 30, that's my dv dt, is equal to 25 over 64 pi. And we want to look at this one. H is 12 feet, so it's 12 squared dh dt. Now solving for dh dt, it's going to be 30 multiplied by 64 divided by 25 times 12 squared multiplied by pi as well. It's going to give me my dh dt. I'm going to get my calculator out, and my answer, dh dt, is equal to 0.1698. And my units are feet per minute. So feet per minute. All right, so let's take a look at our last example here on related rates. So my last example is I have a plane flying at a constant speed of 24 kilometers per hour. It passes over a radar station at an altitude of 10 kilometers and climbs at an angle of 40 degrees. At what rate is the distance of the plane to the radar increasing 3 minutes later? So what I'm going to do is draw a picture. So here's my station down here. And we have this distance of 10 kilometers. Once a plane passes over there, it is going to increase at an angle of 40 degrees. So this angle is 40 degrees. What we want, however, is that value there. So what we're going to use is the law of cosines. And what we have is a squared is equal to b squared plus c squared minus 2bc, the cosine of alpha. And alpha is going to be here. We're going to use this as alpha because that angle doesn't change. Now, just looking at the angle, I'm just going to look at the angle over here. So this part is 90. This part is 40. That means alpha is these two combined. So alpha will be 130. And that's going to be a constant. And what we want is this a value across from it. And in particular, what we want is dA dt. So we're going to see if we've got everything that we need. We have a plane has a constant speed of 24 kilometers an hour. Oh, okay. So we know that this, we'll call this B. So we know that B, I want to do that in a different color other than red. So B dB dt is 24 kilometers per hour. So we have that. And then this value right here, we're going to call this C. Well, dC dt, that's going to be 0 because that is 10 kilometers, isn't going to change. So its rate isn't changing. So let's go back to our law of cosines and put in our constants that aren't going to change regardless. So a squared is equal to b squared plus 10 squared, because that's not going to change, minus 2b 10. The cosine, that angle is not changing either, is 130 degrees. So if we take the derivative, we have 2a dA dt is equal to 2b dB dt, and then minus, well, I'm going to have 2tan cosine 130 degrees dB dt. So I have a replacement for dB dt. We know that is the 24 kilometers per minute. That's also 24 kilometers per minute. What I don't have, however, is right at this very moment, I don't have A and B. But I can clearly and easily find both of those values by going back to my law of cosines and also the fact that they wanted it 3 minutes later. So if we are going at 24 kilometers, let me do that in blue. If my speed is 24 kilometers per, 24 kilometers per minute, so that we're not even worry about units. At 3 minutes, that leg of the triangle is going to be 24 times 3, which is going to be 72 miles. We also know what C is at all times, and we know what the cosine of my angle is. So to find my A, I'm going to have A squared is equal to 72 squared plus, I think it was 10 squared minus 2, 72, 10, the cosine of 130 degrees. So I'm going to take the square root of that answer. I'm going to get my calculator out. So I'm going to take the square root of 6,209.61 and some change. So I take the square root of that, and A is going to be equal 78.8. So now I've got all my replacements. So 2 times 78.8 dA dt, and remember that's what I'm trying to find, is equal to 2 times 72 multiplied by 24 minus 210 cosine 130 and 24. So dA dt is going to be equal to 3,764.538 divided by 2 times 78.8, which will give me 23.89 kilometers per minute. And so there's some related rate problems to help you out on your homework. Go ahead and give your homework a go, and then let me know if you still have some questions.